AI.
The AI will be able to do everything.
Something is definitely changing the world. We need to pay attention. These are not isolated random events. Suddenly, everybody in big tech woke up, and everybody from Microsoft and Google and Facebook started to scramble. By that time, it was clear to these tech giants that AI is the future, and if they invest in AI now, it is going to pay massive dividends. Many people in India may not know that Infosys was also one of the early supporters of OpenAI. This is where all the hype and excitement of AI is coming from. We'll definitely see huge number of AI companies folding up, dying in 25, 26. All the data that is generated in India, at the very least, should stay in India. It cannot be going into foreign data centers. AI is probably the biggest invention humans have ever done. Hello, I am Mukesh Bansal, founder of Mintra and CureFit. In today's episode of SparX, we are going to talk about AI, artificial intelligence. For last 2 years, AI has been the headline news nearly every day. Not a single day goes by before we hear of some new announcement, some new model, some new breakthrough. Every single startup these days is about AI. The governments are scrambling to figure out how they should steer the country's AI strategy in the context of all the geopolitical uncertainty that are all around us. AI is starting to become even more important. And just when we thought the AI hype can't go any higher, we had the last week's 2 Nobel Prize, both in physics and chemistry, are awarded to AI researchers. First one for physics to Jeff Hinton and John Hopfield, who did a lot of pioneering work for AI in 70s, and we'll talk about that. And second one going to founder of DeepMind, Dennis Hassabis, who through DeepMind's work later at Google did pioneering work for solving one very complicated chemistry biology problem, which is known as protein folding problem. It used to take one PhD up to 5 years to solve folding of one protein molecule. Now, protein, as you all know, is building block of pretty much all biology. We have thousands and thousands of proteins that play crucial role in different biological functions, but it used to be very difficult to figure out how one single protein fold, because the folding and the shape of the protein is what will determine the function, how proteins will fold into different structures and so on. What DeepMind did with their AlphaFold AI, they were able to solve protein structure for not just one or 100 or 1000, but over 100 million possible proteins. We don't even know if all these proteins exist or not, but literally overnight, AlphaFold was able to do that. And the Nobel Prize in Biology, which is very unprecedented, was awarded to Dennis Hassabis, who now works at Google. So something is definitely changing the world. We need to pay attention. These are not isolated random events that we have so much hype happening. So many billions of dollars are going to this technology. Everyone is talking about it. And even Nobel Prize in physics and chemistry is being given to AI researchers. What is going on? In today's episode, our goal will be to really break down AI from its original roots. How did AI start? What is working today? Why people are so excited? What is likely to happen in future? What should you as an individual or as an entrepreneur think about AI? What should we expect in the coming years, coming decades? Are all the fears about AI real? How should government possibly navigate those fears? And so on. It is a vast topic. I don't hope to be able to cover everything, but we'll touch upon all the key aspects. Throughout the episode, we'll share some of the books which I think have a lot of amazing content when it comes to understanding evolution of AI. And this, I think, is just a start of the whole series on AI. I look forward to inviting a lot of AI experts in the coming months so that we can keep going deeper and deeper in this very broad topic. I do think AI is one of these defining technology which is going to completely change how the world functions. Now, I have to caution that in last 2 years, I think hype has probably gotten ahead of reality, and that tends to happen when there is a massive breakthrough. Today, AI, while very impressive and very powerful, also has a lot of limitations. So, what we want to do today is really look into all those aspects carefully. so that you can create your own roadmap of how you want to prepare yourself in the best possible manner, so that as and when AI revolution happen, you find yourself on the right side of AI. AI also definitely has the potential of causing a lot of harm, replacing a lot of jobs, threatening national security, and so on. And therefore, everything around AI risk also need to be carefully studied and understood, so that individuals, companies, and nations can take right corrective measures. Let's go back to the very beginning of AI. And we can go back as far as we want, because in some ways the history of AI is really really old. In many ways, history of AI is as old as history of computers. Very first attempt at building a computer was in late 19th century by Charles Babbage, who was trying to build this mechanical calculator known as differential engine. Now his ideas were way ahead of his time, and it never really saw light of the day. But even then, Babbage had the vision of eventually being able to build a machine which can think and reason and problem solve like humans. Fast forward 100 years, around the time of World War II in 1940s, and suddenly people realize that they are facing numerous computational problems, ranging from calculating missile trajectories, breaking encrypted codes, doing calculation involved in nuclear fission, which was required for building nuclear bombs, and so on. And some of the great minds at that time started very seriously thinking about the foundational architecture which can potentially enable machines to do not only complicated calculations but also make them programmable, which means they are not single purpose machine but they can be programmed to do different things. One of the key contributors from this time was Alan Turing. Alan Turing was a mathematician, logician, and computer scientist. He did some outstanding work for British government during World War II, where he helped break the German Enigma code, which directly contributed to the Allies winning the war. But outside of his war effort, he was deeply involved in thinking through what does computing machines can look like. In some of the very early original work, he came up with the idea of Turing machine. Now, Turing machine is a concept which is really simplified algorithm. And what the algorithm says that if you can design something like a Turing machine, it can solve any problem which can be logically stated. And he mathematically proved it. And from there, he conjectured that can we also compose any kind of human thinking as a logical problem, which can then be fed into Turing machine, and outcome will be as good as what a human mind may produce. With this, he devised a thought experiment, which later came to be known as Turing test. The thought experiment was that in future, if you are able to design a machine which can converse with human, and through interaction, if you are not able to tell whether you are talking to a machine or human being, then we can say that machine has the same level of intelligence as human beings. We can argue that most of the GPT like software today have convincingly passed Turing test. We can have very sophisticated conversations with these softwares, and sometimes they are able to answer things way more intelligent than even human beings. You may still be able to tell that you're talking to a machine, and this is probably a subjective test. But the point is that as early as 1951, Turing was thinking about what will it take for machines to be able to think like humans. This idea gained steam in late 50s as we started building more sophisticated computers. John McCarthy organized the very first artificial intelligence conference in late 50s. That's the first time the leading computer scientists from in US came together and openly asked, what will it take for machines to think? Now people were overly optimistic. They thought that we'll be able to solve the problem of human thinking in a matter of few decades. That turned out to be very optimistic estimate, but we seem to be very close to that now. Now, there were different schools of thought of how one might go about s- imitating human intelligence. One approach was that of perceptron, which was built by Frank Rosenblatt in 58. The idea of perceptron was inspired by human neural networks. So we have these neurons in our brains which are pretty much do all the thinking computation inside our heads. Our neurons are connected to each other. There is the learning is captured among neurons through the strength of connections. There is the saying that neurons that fire together wire together. The act of learning involves strengthening those neural connection. Rosenblatt built a very simple computer algorithm imitating how uh, neurons work inside the brain and created a very simplified neural network, which was quite an eye opener. Created a lot of buzz in late 50s, and there were wild proclamation in media at the time that we are on the verge of being able to replicate human thinking. That's not to be, and people who poured cold water on this are some other stalwarts in the field of computer science. Marvin Minsky, which was a towering figure at MIT and did a lot of original foundational work in AI, did not believe in the idea of neural networks. He believed in a different approach known as symbolic AI. The idea of symbolic AI was that we can break down all of human thinking and reasoning into a set of rules. If we just know all those rules, the rules can mean thousands or millions, and then have computers process those rules, they will be able to behave like human beings. Minsky wrote a very influential book called Perceptron, which, while acknowledging the power of neural networks, uh, ultimately uh, mathematically proved that neural networks cannot solve certain kind of problems. And with that, the whole field of neural network went into backwaters. It became it became an area where no researcher wanted to work, while a lot of money was poured into symbolic AI, the so-called expert systems. And most of the AI effort in 60s and 70s was dominated by effort into expert AI. But eventually people realized that expert AI type of systems will not work. They're too complicated, too cumbersome, and there's really no way to encapsulate every single rule that may go into um, forget about solving for human thinking, but even figuring out how does work happen in an organization, how do we make decision about driving a car, and so on. But there were few people who had deep belief that neural networks, these people were known as connectionists, people who believe that just creating this connection of neural networks, you will be able to replicate some kind of intelligence kept at it. One of the key pioneers in this area was Jeff Hinton. He got his PhD in early 70s, and he was a true believer in the power of what neural networks can do. Around the same time, John Hoffield, who was the other Nobel Prize winner of physics this year, created something called Hoffield networks. Again, both of the work of John Hoffield and Geoffrey Hinton heavily leverage some algorithms from physics. They further refined what neural networks can do. And by late 70s, 80s, they were able to demonstrate some simple application for image recognition, handwriting recognition, and so on. Another gentleman got who understood the possible power of neural networks very early on was Jan LeCun. He was working for Bell Labs and doing a project with US Postal Service. Now, US Postal Service was handling millions of letters every day. And if you remember the days of letters, you will realize that you will handwrite the address on the front of your envelope. Now, all of us don't have handwriting that a postal worker can easily recognize. So Jan LeCun was working on building algorithms to solve the problem of can we recognize handwriting easily. And he decided to use neural networks to try to solve that problem. And he was able to produce pretty significant result, significantly better accuracy and reading human handwriting compared to what other humans were able to do at a very fast pace. So there was another evidence that in a limited setting, neural networks might be effective. With some of this early success, neural networks started to gain more attention. Computer science departments around the world in 90s started to take it seriously, and there was some renewed interest in neural network powered research. Another big shot in arm for AI was in late 90s when IBM built this computer Deep Blue, which defeated the then world's chess champion Gary Kasparov. Now, Kasparov at least till that time, was considered the greatest chess player who has ever lived. He was absolutely unbeatable, complete top of his game. But by that time, the computing power was continuing to increase through Moore's law, and IBM believed they now had the computers powerful enough which can analyze not only millions of previous games but also can see any possible moves, many moves ahead, which will again involved massive amount of computation. Now this was not strictly an AI. There was really not much learning involved. It was mostly pattern recognition, married with a lot of computation. But when in 1998 Deep Blue managed to beat Kasparov, it became a worldwide sensation. Again, there were headlines that machines are almost here, ready to take over the world, ready to take our work, and so on. It was not to be, but what it did was it brought a lot more attention back into AI. The amount of investment in AI started to go up. Companies as well as academic institutions started to look at AI a lot more seriously, and that kind of started a renewed interest in the overall field. Around this time, internet was starting to take off. Without us realizing, world started to come to generate more and more data in an accelerated manner, which will come in super handy, as we will see 25 years down the line when we are really ready to build these large language models. But after the big hype around Deep Blue, and IBM went on to further refine the system. They created a software called Watson. At some point, Watson became the world's Jeopardy champion, which is a very different type of activity. It's not like computation where just doing brutally calculating chess moves, but this requires processing encyclopedic information and being able to recall that in the context of question being asked. So this was one more evidence, and again generated a lot of headlines. Great for IBM. Every time IBM will do something like this, the stock will go up. Um, but alas, despite doing so much pioneering work early on, eventually IBM lost the plot on AI. But Watson winning Jeopardy and IBM building a bunch of use cases around potential medical assistant and so on kept the field alive, kept the interest in the field alive. Jeff Hinton moved from US to University of Toronto in Canada, and he started building this small group exclusively focused on neural network powered research. From 1987 till 2012, he kept refining his methods, kept training next generation of neural network believers, and there weren't many. His work was ignored for almost 2 decades. Most people thought that neural network type of approach will not work. It's too cumbersome because it's not algorithmically deterministic. Uh, the learning is a function of data, and it turns out that it required massive amount of data. People felt that that kind of data as well as compute power will never be available. I guess really missing out the simultaneous rise in both compute power and data, which was happening anyway. One of the big breakthrough that Jeff Hinton and his team was able to come through is what's known as backpropagation. Maybe at this point, I'll take a small, segue into a bit of technical detail about how neural networks works. So at the core of it, neural networks are basically maths. It's all number multiplications, and if we talk in bit more technical terms, it's basically matrix multiplication. Now, you might from high school or college may remember a little bit about linear algebra or matrix, but simple way to think about visualize neural networks is that you have a set of numbers organized in a grid. So you can imagine m by n grid. You have a bunch of numbers. These numbers, some of them are known as weights, some are known as biases. Now, let's say you're trying to, let's take an example, very simple example, where you are trying to teach a neural network how to recognize a character, let's say A, B, C, or D. So what you do is you take the letter A, you convert into its all the pixels which add up to letter A. These pixels, again, nothing but numbers. You multiply those numbers with this grid, m by n grid. I'm simplifying dramatically just to give you an idea of how it works. Then you have output number. Now you have a certain output number in mind. If you get that output number, then you say, you mark it as correct answer. There's a feedback into neural network that this computation work. So these weights are on the right track. On the other hand, if initially your neural network recognize B as A, then you give that feedback, and what you're communicating, no, this answer is wrong. So neural network knows that my answer is way off. I need to go back and update all my numbers so that if I were to rerun the same thing, I can get closer to A and not B. This is what's known as backpropagation. What it is doing is you first calculate the loss function. So, what is the delta between the computation for B versus A that you wanted? You take this loss and backpropagate through all layers of neural network, which is basically updating numbers in each previous layer and so on. So you are backpropagating. Now there is a um, algorithm for this known as gradient descent. It took me some time to understand that. It's not easy, especially if you're not trained in maths, but also not very difficult. I think anyone with, there are outstanding videos on YouTube. Three Blue, One Brown is a excellent resource. They have a 7-part series on how neural network works, and I think you'll get pretty decent idea. But anyhow, that was a breakthrough that Jeff Hinton and his group came up with, and this enabled the idea of deep learning. Now, this is what learning, every time you hear about that these neural networks are able to learn, what they are learning is you give a data as an input, it computes what the output should be. If output is correct, it learns that I'm on the right track. If output is wrong, you go back and try to update all the numbers through this algorithm known as gradient descent, and you repeat the process. And after you have done this process thousands or millions or billions of times, you have a trained neural network. And this is the context in which all these terms such as deep learning, because the way, unlike original perceptron, which was a one layer network, here you can have 100 layers, 1,000 layers. So, and each layer is representing some type of learning, pretty much how human brain functions. For us to learn anything, there are different layers of abstraction, and neural networks are able to mimic that. By being able to propagate this loss function, you are able to enable learning in that. Now it becomes such a simple process of, if I have a data, I know what is the outcome I want from data. I feed the data into neural network, I see the computation, then I give the right answer and keep updating my neural network. Now you will hear terms such as supervised learning and unsupervised learning. So in supervised learning, it's you feed a data, for example, a picture of a cat, and neural network tries to do computation. Maybe it says it's a dog. Then the human evaluates that output and says, no, it should be this. You give that feedback, and that feedback is back propagated into neural network, and then you start next cycle. In unsupervised learning, you don't need human in the loop. You just lot of data. As long as data contains what the input elements are, what is the right answer is, and you compile all the data and let the neural network run. And that's really it. It's conceptually, it's not very difficult. All the hype about modern neural network is comes from this ability to learn from data. Now this uh, it looks easy in retrospect. It took people like Jeff Hinton, Jan LeCun, and many others many decades to be able to really figure out the underlying mathematical logic for being able to do that. And the other two ingredient needed for this, one was massive amount of compute power. Matrix multiplication turns out is very difficult, especially for CPUs are the processing units that have been used all modern computers since the early days. It requires special type of um, central processing unit, known as GPU, graphical processing unit. That's what is made NVIDIA now so famous and also so valuable, worth over $3 trillion now, because they are one of the pioneering companies in the world who have been building these GPUs. Now, GPU wasn't really designed for AI. NVIDIA was focused on building this graphical processing unit, which can be used in video games. As you know, in video games, you have all these images which are changing really, really fast. So you need to be able to compute transformation of all those images, which is basically grid of pixels really fast. And hence GPU was architected very differently to be able to do this computation. As people started to do this matrix multiplication for neural networks, they realized that GPUs can be hundreds or thousands of times more efficient. And that is what made GPU the central engine driving this entire AI revolution. Now let's go back to 2012. While I kind of jumped ahead, this transition wasn't so sudden. Jeff Hinton was continuing to make progress with every year being able to eke out slightly better performance out of his neural networks. One of the fortuitous things that happened around that time was this competition, which came to be known as ImageNet. It was started by Professor Fei of Stanford. Uh, in early 2000s, she started thinking about how can we move along the field of image recognition. And she felt, one of the best way to do that will be to organize this worldwide competition where she can invite researchers who are working on image recognition problem. But then the question arose that how will you even judge on which images, people can train an algorithm with their own custom images which can perform better. So you need a standardized set. So she created a project to compile initially thousands of images and eventually millions of images. That database came to be known as ImageNet. And the invitation to researchers was that you can develop any algorithm you like, you can design any which way you want, and then you submit your algorithms. It will be tested against any of those random images in ImageNet. And the team that does well is going to be awarded the prize. Now, in the early days of ImageNet in mid 2000s, there were decent signs of sometimes algorithms will do a good job of recognizing images, and they were slowly getting better, but there was absolutely no breakthrough until 2012. In 2012, Jeff Hinton, along with his his many students, some of them went on to become OpenAI co-founder and starting other companies. They built this neural network-based algorithm, which was able to completely blow past the field and first time demonstrate performance much better than humans. And many consider that as the watershed moment where there was this complex activity, which is how do you recognize image. If you're given a scenery with let's say a picnic scene with there are trees and a lot of humans and animals and balls, and the uh, algorithm is able to accurately describe what's going on in the scenery. And that really opened up people's eye. This was in 2012. And in some ways that kind of brought AI out of the so-called third AI winter into all the hype, which is finally culminated into GPT and other things 10 years down the line. Around same time, another significant development was founding of DeepMind. DeepMind was founded by Dennis Hassabis in 2010 in England with even more ambitious mission. While uh, Jeff Hinton's group winning ImageNet was 2 years ahead of us, DeepMind was founded with the ambition of building AGI, so-called artificial general intelligence. So even way back in 2010, Hassabis and his group was saying that we believe we'll be able to figure out a way to create AI which can match and exceed human intelligence. Now, while that ambition still ahead of us, DeepMind did make a lot of seminal contribution. In fact, after the Hinton's group, known as AlexNet, won the competition, suddenly everybody in big tech woke up, and everybody from Microsoft and Google and Facebook started to scramble, even Alibaba in China, because by that time it was clear to these tech giants that AI is the future, and if they invest in AI now, it is going to pay massive dividends in future. All these companies started actively recruiting Jeff Hinton because by that time he had the best research group in the world. And eventually, Google managed to persuade Jeff Hinton to sell his company to Google and come work with them as a as a scientific director to drive AI research. While Jeff Hinton was there, they were studying what different groups around the world were doing. They became more and more impressed with what DeepMind was doing. And eventually, Larry Page and Jeff Hinton convinced Dennis Hassabis to sell DeepMind to Google for nearly $700 million. Now, for a pre-revenue company, it was a massive amount of money to pay in 2015. But by the time, Larry Page had the deep belief is AI is definitely our future, and he wanted Google to be ahead of anyone else. And it was in some ways small price to pay. This uh, created a lot of FOMO for other deep tech companies. So Facebook started looking for which are the other top researchers, and Jan LeCun had made significant progress by the time. So Facebook persuaded Jan LeCun to join them as head of AI, and he has gone on to do pretty deep work. These days, Llama open source is one of the well-reputed large language model, and Jan LeCun is at the forefront of driving that. 2015 is also seminal because that's when OpenAI was founded. Among some of the original founders of OpenAI were Sam Altman, who pretty much everyone in the world now knows. But Elon Musk, he was one of the founding members of OpenAI and contributed $100 million. Microsoft was an early supporter, and this, many people in India may not know that Infosys was also one of the early supporters of OpenAI. Unfortunately, things changed later on. There was management change and so on, and Infosys thought that purely research-driven project is perhaps not best suited for Infosys charter mission, and they pulled out of their support of OpenAI in 2018-19 timeframe, and perhaps not the best decision in retrospect. It would have been great to have a Indian company also been part of the revolution that's eventually unleashed by OpenAI, but it's obviously very difficult to predict these things in future. OpenAI was originally founded with the mission of building, as the name implies, completely open source AI technologies. The founders of OpenAI at the time believed the AI is too important and too powerful to be controlled by the big tech giants around the world. So their original mission was to do all this work in open source mode so that whatever is developed, the knowledge will be available in public domain. Other people will be able to build solution on top of that. And OpenAI, kept marching along on this mission with that belief and thought process. It was slow going. I don't think anybody was paying attention to OpenAI from 2015 till around 2020. But early version known as GPT-2 started to show remarkable abilities. In science, some of these things are known as emergent phenomena, where you are really not able to explain the end outcome from how parts are stitched together. Biology is a great example of that. It is very difficult to come up with a reductionist explanation of how biology work or phenomena such as chaos and so on. And GPT-2 surprised pretty much everyone, including folks at OpenAI, that how is this able to give such reasonable answers. And GPT-2 also brought attention to the so-called transformer architecture. This paper was published by Google in 2017, and it so happened the lead author Vaswani, as somebody of Indian origin, as well as another person, Nikki Parmar. She also studied in India and later on studied in US and was one of the among the 10 or so contributors to this paper. Now, transformer paper solves something very fundamental. Until then, all this neural network, while they were able to learn from data, they were not very good in learning context. For example, when you say a sentence, if I give you half a sentence, the next word in the sentence is very much a function of what has come before. And what transformer architecture did was brought this idea of attention. Now, again, there's a mathematical definition of attention. 3 Blue, 1 Brown has a great video on this as well. How does the attention mechanism work? I think I'll not go into those details. here, but the core idea is that through attention mechanism, you are able to capture the context really well. And when you are able to capture the context of what is the previous sentence or previous paragraph or previous page, your ability to accurately predict what is going to come next goes up. So transformer architecture, although it did not get a lot of attention initially, in fact OpenAI took it a lot more seriously than Google should have, and hence they started incorporating the learnings from transformer architecture into how GPT-2 was built. And that is really what's led to the so-called LLM models, large language models. So what are large language models? Effectively, they are these massive neural networks with attention mechanism built into it. So what you do is you design these large language models and you basically train the hell out of it. Let me try to describe what large mean here. Earlier I said neural network can be visualized as this grid of m by n numbers. Now and then you can organize these grids into hundreds of layers. Now large language models have initially had billions of parameters, which means the network had billions of numbers which can be trained. And by the time OpenAI moved to GPT-4, which is the current latest model, it has over a trillion parameters. So that's a huge amount of uh, computation that's required to train these models. And to train this, you need enormous amount of data. Now, OpenAI has been really smart about pretty much using entire internet as its data source. So they would have scraped entire internet's data many times by now. Anything that's on Wikipedia, on Reddit, on various forums, everything we have been doing, the stuff that can be scraped from YouTube and so on. Now, it's very peculiar. On one hand, it feels somewhat creepy that all the data that human beings have collectively generated is going into training these models. But on the other hand, this is what's enabling this really sophisticated computer based intelligence that we are able to use for so many possible applications. And without recognizing it, all of us started contributing to this data generation. So everything we do online leaves a trace. Whatever message we post, email we send, documents we create, videos we post on YouTube, tweets we send out, this is all data. Now companies such as OpenAI have created access to huge number of these databases, probably ahead of most people, and that's one big reason why their models are so powerful. Companies like Google, Facebook have inherent advantage because they are fundamentally data rich environments. Every single time whatever search you have done on Google reads. If you use Gmail, every single email is read by Google as a source of data. YouTube is owned by Google, so they have access to all that data. Facebook, pretty much people's entire life is laid bare on Facebook. You've probably been using for 10 to 20 years. Technically, all the WhatsApp data is available to Facebook, although they probably don't use it yet. But I'm sure they have means and mechanism to be able to use that data. And this is what has also in some ways spooked Microsoft. Microsoft is a primarily B2B company, so they don't have access to massive amount of consumer data, and hence they have been very enthusiastic about investing in OpenAI. They are one of the largest shareholder and OpenAI, and through OpenAI, they have access to both all the data that OpenAI has accumulated at this point, but also the technology that OpenAI has developed. So today, with the last 4 or 5 years of effort, after GPT-2 demonstrated what is possible with the transformer architecture in large language models, it basically unleashed an arms race of who can build the bigger model, going from few billion parameters to few tens of billions, hundreds of billions parameter, and who has access to lot of data to be able to train these models. At some point, it became extremely expensive. Today, to build a modern large language model from scratch, which is comparable in size to Llama or Gemini or Cloud, it will cost hundreds of millions of dollars because processing all the data, computing all these numbers in these neural networks, computing loss function, back propagating it, running these cycles millions of times over and over again is very compute intensive. You might have heard news that today AI in the world is consuming um, up to 10% of all electricity in some countries on a daily basis. So it's can imagine the amount of power that's being consumed by these models because they are so compute and data hungry. But there is absolutely no denying that these models are really powerful. I'm assuming most people listening to this episode would have been using either GPT or some other models on a regular basis. I use all these models almost nearly every day. These days, when I'm working on really anything, researching for something I want to write, the work I do for my book, or a problem I'm dealing with, my first go to resource is GPT. And it's really incredible that if you give very structured prompt, it is able to generate output that can save you hours of work. In the past, something will require you to either spend many hours doing it. For example, if you haven't done this already, you should really do that. Take a PDF of a book, upload it to GPT, and then pretty much ask it any question, and you'll be quite surprised. Whether you want summary of the book, key highlights, great stories, quotes from the book, and so on. Literally a matter of minutes, you will have all of it on your fingertips. You can ask GPT to create an Excel document for you. Something that's really powerful is you can ask it to write code. And I've done this now many times. You give a problem statement, say, can you write me a Python code or Java code? You copy that code and you can run it in your whichever development environment you like, and the code just runs. It's mind-boggling to think that all of us today have this AI on our fingertips, which can do so much and more. You would have seen all these software which are able to generate very realistic images that based on a different architecture, what's known as diffusion model. Diffusion model some works very differently than large language model, which are based on next token prediction. Diffusion model, I'll again not go into details, but what they do is they're able to use two neural networks, and they're able to first introduce noise, so make the image very blurred, learn from that, and have the ability to again just start from a random noise of image, and based on just few input keep refining until you have an image that you want. There's just something, platform like DALI or Midjourney you might have tried to see. New development with LLMs is people are starting to develop what's known as multi-modal models. What that means is that instead of only dealing with text tokens, these models can now deal with image tokens, audio tokens, and that's the next evolution of large language model. GPT-4o has this capability, and all the new avatar of all large language model are likely to be going to have this capability, which will make these models even more powerful, so that through same technique you can deal in text, you can deal in images, you can have it create audio, and I'm pretty sure very soon it'll be able to create compelling videos as well. You might have seen the Sora video that OpenAI released, which is a demo version, but it demonstrates the possibility of creating very realistic videos. One of the uh, very promising AI capability, which is pretty much here, is the ability of AI to converse in human like voice language. Again, this is not science fiction. You can try it today or download the latest version of GPT-4o, enable the voice mode, and try to have a conversation with that. You can have pretty much any conversation you like, and you'll get very realistic human like answers. For you can talk to it as your therapist, you can ask it to solve an engineering problem, you can ask it to tell you a story to lift your mood, you can plan your vacation, and all through a voice conversation. You can even talk to this in Hindi or any other Indian languages. Now today these capabilities are not very strong, but just a matter of time. uh, GPT-4o can already understand hundreds of language, and very soon, pretty much all these models will have able to support very sophisticated conversation, pretty much all the languages known to humankind. And you can just imagine the power of that to transform how we live, how we work, instant translation from any language to any other language, being able to communicate with anywhere in the world. For companies, they will be able to enable a lot of voice powered use cases where you call into a number and you have a AI assistant at the other end, which is able to have a conversation with you as slow as fast you would like, understand all your context, being able to give you very reasonable answers. And it's mind boggling to think that all of this is already here in our. We just need to download something or sign up for one of these services and we can start playing with technologies. And this is where all the hype and excitement of AI is coming from. So let's look at where we are in AI. One of the key things for anyone interested in technology to keep in mind is the exponential nature of technological progress. I'm sure you've heard about Moore's law, which has pretty much doubling of computing power for same price every 18 months, and that has gone on for over 60 years now. And we covered the power of compounding earlier on. If something keeps growing at an exponential rate, it becomes absolutely stupendous. And I think we are seeing that happen on AI front from the humble AlexNet just 12 years ago, where being able to even identify picture of a cat accurately was a big deal, to these large language models where we feel almost comfortable even asking for a medical diagnosis or preparing a legal brief or giving a science tutorial and so on. We have come a long way, but we are not done yet. It's almost a given that we can expect these technologies to keep getting better every year. Um, the total impact of what has happened in last 2 3 years is going to play out over next decade or so, and that is very important to understand. It is safe to say that barring some of the folks in big tech and some computer science departments, not many people were paying attention to AI. GPT-2 and especially GPT-3 completely changed all that. Since then, there's probably more than $100 billion which has gone into AI related startups. All the big techs are spending tens of billions of dollars. Now, as you know, the all the big tech companies around the world, they are massive, they are very powerful, they are these profit generating machines. Companies like Facebook, Google, Microsoft, and even Nvidia now, they generate between 50 to $100 billion profit every year. So for these companies to invest 10, 20, $30 billion a year into AI is really nothing. And if that is what ensures that these companies have a leading role to play in the world in the coming decades, they will obviously leave no stone unturned. But it has also, the promise has brought in a lot of VCs. Huge amount of VC private equity capital is going into AI, and some of the best entrepreneurs around the world are also working in AI. Now, when you have this kind of moon landing movement, uh, the ripple effect of that is going to play out for a long period of time. Now, with so much intellectual capital, financial capital, computer resources going to AI, profound things are bound to happen. It is inevitable. But first, a word of caution. I think another thing which is very well known in people who study technology is the so-called hype curve. What happens? Hype curve is some breakthrough happens, and everyone start thinking, world is going to change overnight. It unleashes the whole gold rush mindset. A lot of people come in, looking to make a quick buck, massive impact, and so on. But more often than not, the promise does not immediately translate into an outcome or impact. And I think we are seeing that in some ways with AI. In 2023, there were huge amount of funding, probably tens of thousands of interesting startups around the world. But if you look at how many startups are able to translate that into revenue, or even for big tech companies, despite their impressive demos, very powerful technologies, how much of that is directly contributing to revenue, except perhaps for Nvidia and all the cloud providers, which are definitely raking in money with really no end in sight. But the commercial application of AI are still far from large scale monetization. There's a pretty decent chance that next couple of years will be slow. People who rushed in and put in a lot of money, they will be expecting short term returns. But I don't think there are too many short term returns to be made. It is going to be a long term game. And as a result, some people will start to lose interest. We'll definitely see huge number of AI companies folding up, dying in 25, 26. But the real game to be played here is for the long term. So now coming to what you should do to prepare yourself to for this coming AI revolution. Uh, if you are an individual, I think best thing you can do is make AI your friend. Make sure you play with new tools as and when they come up with. Try to find applications in your everyday life where you can uh, create some kind of advantage for you. Learn as much as you can about AI. Now, depending upon your background and interest, there are the, there are a lot of interesting books. In fact, few that I have enjoyed in my journey with AI. So one is Genius Makers. It has an outstanding history of the evolution of AI, all the key characters, some of whom we touched upon. Master Algorithm is a great book which goes in somewhat technical details about what are different approaches to AI, how does it work computationally, mathematically. Super Intelligence by Nick Bostrom is a great thought provoking book. It really lays down both the potentials as well as potential pitfall from this superhuman AI, which we may see in our lifetime. The book by Fei, Worlds I See, it's a great, memoir come history of AI tour. I immensely enjoy reading that book. And then somewhat technical book, Why Machines Think, recently came out. It goes into the technical details, but still fairly accessible for people who are interested in really understanding how these LLMs are working. So using these books, or there's a great online content that you can consume to just learn. I think last thing you want is see this technology completely change the way things happen around us and not being able to fully understand, appreciate, or incorporate in your everyday work. If you are a manager or a leader, this needs to be a strategic priority for you. If you go back 10 years ago, some companies were very early to adopt mobile phone technologies, which gives them a distinct advantage. I think same is happening with AI. Whatever processes you have in your organization, you need to ask the question, can AI change how I work today? Can I make my team more intelligent? Can I make my team more productive, more efficient? Can I improve quality of outcome for my customers? And it's not like there is single silver bullet which will solve for everything, but there are tons and tons of solutions. Even if you fail to create a production ready impact today, just doing pilots with these technologies is going to prepare for you for what's to come. You'll get more and more comfortable. Change management, whether in our own behavior or in the organization, is not very easy. It requires sustained effort, and if you haven't already started, you have to start now. If you are a startup entrepreneur, you need to really understand that there's a class of AI companies which people call them AI wrapper companies. What is an AI wrapper company? You find a use case. Let's say you want to create something which can create automatic summary of reports. So you write a simple program where you call OpenAI APIs, you send in your prompt, get the feedback, and publish that. Now that'll look very impressive, but you've really not done any value add. All you're doing is calling in OpenAI APIs, which somebody else can do. So as a AI startup, you need to think about what is it that you can do fundamentally different. Are you in some ways able to make the large language model perform better? Are you able to create a unique ability? Deploying large language models in the real world are still hard. They need to be trained. Hallucination is a huge problem. Quality of outcome is not deterministic. At some point, maybe at odds with what our organization is trying to do, can really cause real harm for in the production environment. So, as a startup, you need to think about that. Are you really solving any fundamental problem? If you are not, your staying power will be limited. There will be countless other companies who are doing the same thing. You will not be able to differentiate. If you are in policy, I think it's especially true for India, the policymakers in both state and national level need to pay a lot of attention to AI. We haven't paid so much attention to both rise of internet and mobile phones, and today the entire internet is controlled by foreign companies in India. Entire mobile infrastructure by and large is dependent on technology that's imported from outside. That's also true for electronic vehicles. But for AI, India cannot afford to be so dependent only on these large language models built and controlled outside. Um, as we discussed earlier, one of the biggest ingredients for powering AI is data. Now, India is data rich in its own way. We have a lot of cultural heritage, a lot of India specific problems, India specific data, regional languages, and so on. There needs to be huge sense of urgency to make sure that data is protected. All the data that is generated in India, at the very least, should stay in India. It cannot be going into foreign data centers because there is absolutely no doubt it will be used to train some other language models, and eventually Indian companies and Indian users will be paying for those services which are created by leveraging data originating out of India. We also need to think deeply about the foundational models, just like operating system and CPU. This is going to be a foundational technology. Pretty much all AI application will require working with some LLMs. While there's some effort in India like Servam AI and Kritrim by Ola and few other efforts, there's really no large scale, heavily funded effort that anyone in India is able to marshal together. Now that's a huge worry. What is the future we are headed towards? Are we going to provide all government services, all public services, all consumer services only on top of OpenAI and Gemini and Llama? You know, there is, we should not be naive to think that these are going to be free services in future. Just like we are, Indian companies are paying huge internet tax today to advertise on Google and Facebook. We'll be paying tax to all these LLM providers in future unless there is something indigenous created outside India. But for that, India needs to marshal a large scale public private partnership. It is going to cost hundreds of millions of dollars. It needs to be heavily funded. It needs to be national priority. It needs to have the best people with the right incentive working on it. Um, while there's a lot of talk about AI and there's a lot of genuine interest, it needs to translate into adequate resource allocation and creating a project with sense of urgency and with deep commitment. Otherwise, we are going to end up heavily dependent on these LLMs, and they are getting more and more expensive to train. Uh, they are coming up with new capabilities which are continue to surprise uh, what they are able to do, and getting very close to finding real world production application. So just zooming out, we have briefly covered history of AI. What are some of the breakthroughs which has enabled all the excitement of AI? We are living in absolutely magical times. uh, AI is going to change our world today. Today as humanity, we face a lot of problems which are quite intractable for us. But in AI, we are likely to have this super intelligent partner to collaborate with, which can significantly augment human intelligence, our ability to go after whether it's science problems or social problems or climate problems, so on, is going to get dramatically enhanced. But all of us need to prepare to not only adopt this technology, to understand this technology, to create unique solution, but also take care of national interest to make sure there is a long-term agenda to design, own, and steer the growth of this technology, which is going to play huge role in our lifetimes. Next 1 or 2 decades are super exciting. Given the exponential rate of growth our technology can do, where we will be in 5 years from now or 10 years from now may be absolutely unrecognizable. There are huge number of social, implications with the rise of AI. That's perhaps a completely different episode altogether that we'll come back to and have a deeper discussion. One thing, where I want to end this episode on is recognizing that AI is probably the biggest invention humans have ever done. It is getting better really fast. We are able to see a lot of real world use cases. The pace of change is only going to accelerate, and it is important, I think, for all of us to understand, to embrace, to incorporate AI in everything we do, and also to be very watchful about how we let the AI ecosystem develop and how we as a country choose to be autonomous and independent in development of the AI roadmap for the country. Hope this episode has inspired you to recommit and look deeper into AI. There's huge wealth of resources. I think on this podcast we will have many such episodes. We'll talk to a lot of experts around the world to break down AI for practical implications for your everyday life and how you can create a roadmap for yourself, whether in personal capacity or professional capacity. But super exciting time ahead and looking forward to having more conversation on this. At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.